let's start. Yeah, okay. So today we have the pleasure to have one of us, Z, which is he's a PhD student at University of Sheffield, which has just submitted his thesis, and is an upcoming postdoc at the Digital Democracies Institute at Simon Fraser University. I know Z for a while now, I think from Alex 2017. I'm really happy that we got to do this together. And I'm very excited to what he has to say on what he did during his PhD. So take it away.
Cool, thank you. Yeah, I'm really excited about this. This is also the first draft of the slides I'll use for my defense. So if you come here, you don't have to come to my defense if you wanted to, because I'll say exactly the same things. But given that, feedback is super welcome. Like if there's something structural or some of my points that aren't clear, I'd love to hear it. And yeah, questions are more than welcome too. I just finished the slides literally like a minute before I joined the Zoom call. So I don't know how long they're going to take, so let's just go on a ride together and see how well it works. So just as an outline, I'm going to start by, there's just going to be a quick, brief introduction. Then I'm going to move into the experimental chapters. And then I'll start talking more generally about how we conceptualize abuse detection and how we conceptualize machine learning and how that influences. I'm not going to have any examples of abuse in this talk, so you're just going to have to trust me that abuse exists and that there are some things that we want to moderate. Or you can read my thesis, but please don't read my thesis. It was awful to write, so I imagine it'll also be awful to read. I'll probably swear and refer to slurs, but I'm not actually gonna, it's not gonna be on any slides or anything. So the first things first. The title of my thesis comes from this song "All Good" by De La Soul and Shah Khan, which is still an amazing song. If you haven't heard it, you should definitely go check it out. Second disclaimer is I don't use the words train or training in this talk because the words train and training assumes that a model has learned something. And I'm pretty sure that everyone in this call and watching will be pretty clear on that. Machine learning models don't actually learn anything. They optimize for something. They optimize for some objective. So following Kulinich, I will be using optimizing instead. Similarly, I don't use the term automated or automatic because it to me it implies some degree of intelligent autonomy beyond just a procedural intelligence. Instead, I use the term machinic because it's machines that are doing something procedural. So first, the problem of online abuse. So online abuse has been exists quite widely. It's a relatively small portion of content. Estimates are between 2 and 5% of all content is abusive, but it gets a lot of attention, and both because it's promoted quite a lot through algorithmic systems, but also because it affects people quite strongly. And there can be many different forms, like misinformation, harassment, hate speech, are all different forms of abuse. In this work, I focus on hate speech and offensive language and harassment, but it's a wide space of things. Hate speech becomes contentious. The discussion of hate speech becomes contentious because people set it up against freedom of speech. So whether you moderate something means that in many people's eyes that you also remove something. And I don't think that that's necessarily true. And I think the freedom of speech argument is honestly kind of lazy. because by having the space to abuse people, we effectively are saying that some people's right to speak matters more than other people. It's not, because what happens in reality is that marginalized people, and people who are not belong to the majority or to the majoritarian group will likely be marginalized and will be silenced. So when we say, well, abuse, like we should weigh freedom of speech more, what we're effectively saying is we should shut up people who go against the majoritarian discourse. And like the distinctions here between like outright silencing minorities and political opponents or whatever isn't that big. Like we're just saying that, well, because this is a specific group that we think are more important than the other groups that are smaller, we should just let them speak, or we should just let them silence them. So I think that the free speech argument is kind of like, it's bullshit, to be honest. Also, it assumes that speech has to be universal for everyone. Or it's not universal or it can't be universal for everyone. So we never work with this assumption or idea of, well, we can have different understandings of what acceptable speech is depending on the group. Like and that kind of plays into like, if some specific group of people have a way of referring to themselves that might be offensive to people outside of the group do it, well, that should be moderated equally, or it should, like, everyone should have the same kind of affordances to use that kind of language, which erases like a lot of gray areas, and like the world is generally just, gray areas, and particularly when it comes to matters of speech. Oh, there we go. So a place, as I've kind of alluded to, a place comes, like this all becomes very contextual and very situated. So in a very direct example, I don't know how many times the words "fuck you" have been shared between Yanaya or myself or any other of my other friends. But like, it's obviously very different from when I say "fuck you" to people who are being actively racist or people who are being dicks. When I'm just saying "fuck you" to a friend, and it's kind of like, oh, you have a good point. Like, fair enough. I give up. You won this argument, or you won this discussion. But they're very different. So context makes things very hard to define what's hateful and not, because if someone says "fuck you" to me and they literally mean me harm, well, then that might be hateful. But if we're just friends and we're joking around, that's fine. Another real life example is it okay for me to use anti-Semitic tropes? So my background is I'm Pakistani Muslim, and for some reason I have a lot of Jewish friends compared to like the size of my friend group in general. And my Jewish friends and I, or some of them, make very, very offensive jokes to each other. They make jokes about Muslims and Pakistanis. I make jokes about Jewish people, and it's very much not okay outside of any context besides that specific thing where we both know we're making fun of, like, we're in a situation where we're making fun of not just the tropes, but also each other, and we're just being a bit playful. So is that okay for me to use those jokes? Is that okay for me to use anti-Semitic tropes then in jokes? And is it okay only if the other person also uses Islamophobic ones? And moreover, is it Islamophobic of me to use Islamophobic tropes and jokes and make fun of my own, like make fun of things that might ring true to some degree but largely aren't? The answer is it all depends, right? There's no single perspective that's universally applicable. There's no specific place in time where we can say, now we have a definition that is true for everyone. we have to look at every single instance and say, well, what is it special about this instance for us to understand what's going on? And because of this, what we end up with is neither words nor tropes. There's very little that actually functions as reliable signals for what is abuse and what is not, what is hateful and what is not. But like, so what do we do then? Like, we need to take some sort of place of saying, well, we need to be able to agree to some degree that there's something that we construe as abusive or not. And so there's a lot of negotiation that happens there. And to identify what kind of, like, it's important for us to identify what kind of context matter and what doesn't. The machine learning way to go about this we have some data set that's labeled, and we're going to assign some weights to some features. But because features or like words are unstable signals, machine learning overfits because it's unable to consider context. And this brings us to discriminatory machine learning systems in part. The other part is that machine learning builds on the data that comes in, and the data that's annotated for abuse very often encodes structural perceptions of acceptability. So machine learning and annotators are unable, so they have encoded some perspective on what is acceptable. Is it acceptable for a sentence devoid of context to contain the N-word? Well, that very much depends who wrote that. Who were they writing to? What is the purpose of it? If it's a Black person who wrote it, yeah, that's probably fine. If it's not, then, it's probably not. But a lot of these things are hard to handle, right? So, and they're hard to handle for machine learning inputs or machine learning models when they can't trust the input that they get. So that leads to the first work I've done in my thesis, which is trying to think more carefully about how we can think about words and tokens and features and input for models that reduces the issues of surface forms or like of words and the unreliability. So the question here is, well, the question I'm asking here is, well, if we can't trust the words as they are, is there some representation of them that we can trust that might give us a little bit more information? And maybe to address the issue of overfitting, one question is just, is there a way to reduce our feature space? Like, can we have less features that are more complex and that mean more, but are also much less, are also much smaller in just the raw number? And then what is the influence on optimization time when we limit the vocabulary in this way? So I use 3 different types of tokens, or like tokenization. So first is just a unigram surface word forms. I don't do any stemming or anything of the sort. I just clean it up to make sure that each token is, or like each word is indeed a token of itself. But I don't do any modification to it besides lowercasing it. And all at user or user mentions are reduced to a user token, and so on. URLs are reduced to a URL. The second thing that I do is I represent things through the byte pair embedding vocabulary that's been created by Heinzelling and Strobe. So what that does is just compute subwords of the entire data sets. I don't make a limit on the number of subwords. I just say, well, everything that you create, that's fine, because I'm not training the embeddings. It doesn't really matter that I don't know that I just say use all of it, because I'm not trying to figure out like what are useful subwords for this specific data set. The third is the linguistic inquiry and word count dictionary. So this is where the feature reduction happens, or like the feature space reduction happens. There are 92, like Luke contains 92 dimensions, and it's developed to identify psychology relevant categories in text, to be able to, through quantitative methods, understand how people are communicating and their emotional states. And the dimensions are like, they have 4 summary language variables, or like analytical thinking, cloud, authenticity, and emotional tone. 3 descriptive categories like how many words per sentence and so on. 21 linguistic dimensions, for instance, the percentage of the words in the text that are pronouns, articles, blah, blah, blah. And then there are 41 categories that are tapping into psychological constructs. That is affect, cognition, biological processes, drives, so on. 6 of personal concern, work, home, leisure, activities, and so on. 5 informal markers, and this informal language markers, and this becomes quite important. Like it's accent, fillers, swear words, and net speak. And we'll get to how this actually looks in a couple of moments. But and then they have 12 punctuation categories. So all of the data is labeled into these different categories. Right, like all words are labeled into the different categories. And like I use 5 different data sets because they measure 5 different perspectives on abuse and hate speech, and I process them all through these tokenization processes. They're all binarized. All data sets are binarized to be able to measure generalizability between each other, but that requires certain reductions and certain abstractions to be made. For instance, I specifically, when I do this, I say that, well, it doesn't actually matter whether it's racist or sexist. It doesn't matter whether it's offensive or it's hate speech. They're all going to be slapped into one category. That is abusive. Most of the data sets heavily favor the negative class, with the exception of the offense data set, which is by Davidson et al. Each of these data sets have different goals, but there are some shared values between the different data sets, or shared goals between them. The offense and toxicity data set try to pick out the same things. They both try to identify, well, where are the limits of acceptable speech for having an online conversation. The hate speech and the hate expert data sets, which are distinguished by their annotation process, not their goals, ask, well, what is racist? What is hateful versus what is not? And the Stormfront data set, which is collected from a white nationalist website or web forum, the oldest one, in fact, called Stormfront. That data set also asks, well, what is hateful and what is not? So there are some shared goals between them, but they're not necessarily, like, they're not perfectly mappable. Okay, let's see if I can play this.
Hold on a minute. Hello?
Hey, how's it going, you big cockney space case?
Shut it.
Listen, did you manage to shift that ticket for tonight's spiritual gathering?
No, mate, no, not at all, no.
Oh, nice one!
Why, who needs one? Who?
Lulu.
Oh, sweet.
As sweet as, mate.
Cool.
For fuck's sake.
I'll catch you later, mate. Don't go changing, try and please me, all right?
Yeah, nice one, bruv, yeah.
Oh, nice one, brother.
Nice one, brother.
Nice one, brother.
I said, nice, bruv.
Nice one, brother.
I said, nice, bruv.
Fucking nice one, brother.
Nice one, bruv. Brother.
Fuck off.
Okay, so that's a little clip from an amazing movie from the 90s called Human Traffic. I highly recommend watching it. It's fantastic. But what I want to look at is how do these different tokenization methods actually influence, and how do they end up looking? So if we look at the sentence, fucking nice one, brother. We can see here how the surface form and the byte pair embedding form are kind of one-to-one mappable, but they split up once there's an unrecognized word. This is then 2 tokens instead of 1. If we look at the loop categories, though, each underscore symbolizes a different dimension, different loop dimension. So we end up with a many-to-one mapping of like many loop categories to a single word. And then we have one that only has one. But interestingly, this dialectical marker of brava or bruv becomes an unknown token. So there's a lot that isn't recognized. And the same is going to go for NetSpeak. So even though they say, well, we collect NetSpeak, there's a lot that they're not going to collect, because like the word bruv or brava would be fairly common if you just look at like English Twitter. And by English Twitter, I mean like UK English Twitter. So like BPE looks like it would be represent words represented quite well and represented quite closely to the surface forms, right? Well, let's see how this actually influenced the tokenization and like the distribution of tokens over classes. So on the left, we have the surface form, and on the right, we have the loop categories. So as we can see in the surface forms, the vast majority of tokens belong to either one of the classes, like either abusive or non-abusive. But once we do this reduction down, most of the tokens by far are shared between the two classes. So effectively, we say, well, we're going to provide the system with less to overfit to, right? And just to have some raw numbers to look at, here are the vocabulary sizes in raw numbers. So we go from like 14,000 something down to 800 unique tokens. And similarly, the largest reduction is in the toxicity data set, where we go from 95,000 something tokens down to 1,000 tokens. So yeah, I mean, we would assume that this would then mean that models aren't going to work very well on it. I look at some specific models. I look at MLPs, CNNs, and LSTMs, and I don't use pre-trained embeddings because of the nature of how Luke is, like what Luke is developed for. It doesn't make sense to train Luke embeddings, right? It doesn't, like, it becomes kind of nonsensical to train Luke embeddings when it's not meant to represent a sentence. It's meant to be analyzed in aggregate. Like, there are so many emotion words, there are so many swear words, and so on. So I don't use any pre-trained embeddings. And just to have a look at how the parameter sizes of the model, like the size of the models change, well, we see like massive reductions as soon as we reduce our vocabulary by that much. And like they're similar across all 3 data sets. This is just for one of them. And because like there are a bunch of slides, or not slides, there are a bunch of figures in my thesis, I've just like decided on focusing on one subset of results and speak more generally about it. So all the results here are trained on the offense data set, or like are optimized on the offense data set, but roughly represent a general trend across the different data sets. The 3 things are clear here, and I'm not sure if you can see it, it might be too small. And they're not all clear here, but when we look at all the results, we see that in domain models, rule supreme, they work best. That's not surprising. The surprising thing is that loop-based models sometimes perform surprisingly well and sometimes underperform. And we see a really interesting effect on dataset effect in cross dataset prediction. Some loop-based methods perform highly competitively out of domain. Like if you look at the top left one and look at the very top bar, so that's an out of domain model that's working, like that's predicting at 85%, or like 85 F1, which is surprising for any out of domain model to be working that well. And what we see here is that it's because there's something about the data sets that agree. So the hate speech and the hate expert together work well, and the offense and toxicity. What's also interesting here is that this effect is only observed in one direction. It's always the larger data set that works better on the smaller data set, which I think is quite interesting. So now turning to like optimization in time, like how quickly our models are fully optimized. I measure this in terms of minutes, and I'm only looking at optimization time, not inference. So one thing that's clear is that the results are complex. There's not any clear pattern, but there are some very interesting indications here. And partly what makes these patterns unclear is that, or makes them complex, is that we will all of a sudden have some models that train really quickly, or like that are optimized really quickly for reasons unknown. Let me just see if there is an example here on this one. Yeah, so the word LSTM here, on the left one, it's the yellow bar in the middle. Trains, or like is optimized really quickly compared to the fact that it's an LSTM. If you then look at the byte pair encoded LSTM, which is the largest bar, it's several times slower, and like there's not a significant difference in the tokens or the token distributions between those. So there's something quite interesting going on here. And similarly here, like if we look at the hate expert one, and
how do you measure the optimization time, like until it reaches some saturation, or what?
Yeah, I mean, it's basic. I set a timer to start just before I start the optimization procedure, and I end it right after it stops. So when the model is fully optimized, when I exit my routine, that's I measure the time that goes between there.
So this is based on some performance on the development set?
No, I mean, it is just like, so this is not normalized for the size of the data set, which is a very good point. That's a really, really good point. But basically, it's literally just saying, start timer here, start procedure, end procedures, end timer.
No, so the question is like, what is the procedure? Like, do you say, okay, let's train for 10 epochs, so based on some development sets performance or stability? Or, there could be different strategies which would lead to different time.
True. So this is based on development set performance. So I use early stopping, so the number of epochs is like uncertain. But yeah, it's for some set number of epochs until early stopping is triggered. Yeah, I mean, I think if you look at optimization time in terms of how long each epoch takes, you're going to get a different result. But I'm not sure how different it's going to be. And like, there's something I don't know how to analyze this. I don't know what to conclude here, because when I look at so on the top right one, the top bar is a Luke CNN. That takes a long time to optimize for. It's twice as slow as the word CNN, which is 3 times as slow as the byte pair encoded CNN. This doesn't make any kind of sense to me. But what this does suggest is that there's some effect between the vocabulary and the class manipulations that are non-trivial to identify. My educated guess is that by making the vocabulary less unique to each class, or to any specific class, so we basically have a lot more of the vocabulary that's shared, there may just be more parameters that need to be updated in any given iteration, because we're going to see things more often. But I'm actually not. That's really just a guess. But what I can say is that loop modeling doesn't save that much in terms of time, but it can be much quicker. The real winner here is that, the real thing we can take away from this is that abstracting away from surface forms can help out of domain performance depending on dataset affinities, which makes sense. Which makes sense for an actual use case where you'd want to have, where you create a data set of what you identify as abuse, and you want to apply that to your platform. So the second bit of work that I've done is around multitask learning, and this is joint work with Joachim Bingel, who was at Copenhagen University but now is at Hero IS. And the central questions here is, if there's some context that matter, how do we know which ones? Do we know which ones, and how do we know that? Is it primarily abusive language detection tasks that are helpful? Or is it tasks that are unrelated to abuse? And how does that influence combine? Does it even combine? Is there a positive or a negative effect? So for the primary tasks, I use three of the data sets that I've already used. I use the 3 largest data sets that I have available. In earlier work, I showed that hate speech detection tasks help, but have a limited it's limited how much they help. Since I've submitted, Paula Fortuna and her colleagues have found that data set affinity again matters. That's quite predictive of how well the models are going to work, or how well the auxiliary task is going to work and how well it's going to generalize. In this, I don't binarize any of the tasks because I'm not looking at generalizability across data sets. And for the non-abusive tasks, Rajamanikam et al. Showed at ACL 2020 that emotion detection can be really helpful for abuse detection. So the question then becomes, which non-abusive tasks are useful? And yeah, okay, I think I'm gonna, okay, I don't want to do that. Cool. So the ones that I choose are focused in part by issues identified by Rutka et al., and that's coming out at ACL now. But one of the issues around that they identify is sarcasm detection or humor or irony. The other 2 are things where it's been argued before that these things probably matter. So whether someone is making a feeling-based argument, so whether someone is always abusive or often abusive, or it's just a moment in time where they are abusive. So to that, I use predicting whether or identifying whether an argument is based in facts or feelings is useful. And finally, I use moral sentiment, which just seemed highly relevant. what are these saying? Are they saying that they care about people? Are they saying that they want to induce harm? And moral sentiment is like split up into pairs of, I think 5 pairs of mutually, or 5 pairs of opposites. For the tokenization, I just use unigram word forms of the surface forms and the bipair encodings because this is more of a traditional task, and I don't know how well Luke would actually map to the other tasks. So on model design, I have signal task SVM and an MLP to have a linear and nonlinear model, and an ensemble to have something that looks sort of like a multitask learning model. For my experimental models, I have a multitask NLP, which is a hard parameter sharing model. And the optimization procedure here is for every single batch that is selected, it is selected given a probability of each task. So the main task always has like the highest probability to make sure that is chosen most frequently, and the model is primarily optimized for that. But the auxiliary tasks are then chosen with a probability equal to each other. So one of the instances is 0.6, 0.2, and 0.2. So 60% of the time the main task and 40% split among the 2 auxiliary tasks. I cap this at 300 batches per epoch because otherwise I'll just be training on the entirety of the data sets, and it's just going to be a much slower process. And given that, and between each epoch, I randomize the data set, or like the data order. So I'm going to get a look at most of the data sets, probably all of the data sets, given the number of epochs that I run. I don't use pre-trained layers because I want to investigate the impacts of the tasks, not the impacts of the task plus the random factor that is contained in the embeddings. Cool. Okay, a lot of notes here. So on the results, so I'm not sure if you can see the numbers because I don't know if the signal is clear enough. But the numbers are across 5 different runs with different random seeds. And for this data set that I'm showing the results for, the experimental models outperform the baseline models, but that's not a guarantee. For some of the other tasks, they don't outperform. They still outperform. They always outperform the single task MLP baseline, but the other models or the other baselines sometimes perform surprisingly well. There are some interesting patterns across the data set. So the ensemble class baseline is really, really bad in almost every single case. Another thing is that abuse data sets on their own can be useful, but only if there's a data set affinity. The combination of a non-abusive task can also be helpful, usually is quite helpful for most of them. But what really works well is the combination of a single abusive task and 1 plus non-abusive tasks. There's no clear indication of what non-abusive data sets are most useful, except for the fact that the sarcasm data set, or the sarcasm model, the sarcasm data set is always in the top 3 best performing models. And interestingly, the moral sentiment is the only one, it's the only auxiliary task that is tweet-based. And I would have imagined that would, both that it's tweet-based, but also how closely related the concepts are, that it would matter a lot more. Turns out it doesn't. It's one of the auxiliary tasks that's useful for some of the data sets, but not for this specific one. And generally, the baselines have better recall, but the experimental models have a better precision, which is what drives the improvement. So the takeaways here are, if you only have abusive data sets, then only use one of them. And when you're choosing which data set, look at the annotation guidelines, look at the goals of the data set, and select them based on that. If you also have non-abusive data sets or data sets that aren't related to abuse, then you're going to need to test out their combinations. What I would recommend there, or what I found, is that once you have an abusive and a non-abusive data set, and you do that pairwise for all of them, all of the combinations, of where you only use two, you're going to be able to identify which ones are going to be helpful. And you don't need to look at 3 or more, but you can do that afterwards. Adding, so something more that's interesting is that adding auxiliary tasks also makes the models perform more stably across the different metrics. That's the word. Yeah, so there are some benefits to using multitask learning for abuse detection. So next is, like, now we're kind of done with the experimental part, and I have about 5 to 10 minutes to go through the experimental part. So here I'm returning back to the question of, well, what are we actually doing here? In this work, which is the product, or like a subset of joint work with Nana Tulsvik from Copenhagen Business School, what we're looking at is what does abuse mean? What is toxic, offense, or hate speech? What's contained in these categories? What's contained in these concepts and constructs? And like, what does it mean for notions of acceptability? So Britney Spears, because we're talking about toxic content. But if we look at the literature on abuse and on abuse and hate speech, a lot of it is rife with metaphors and links to dirt and toxicity and pollution. But the question is, what is dirt really? What does it mean for something to be offensive or toxic? And what does it mean to clean that up? What are the implications of creating such categories, and who's affected by that? So, as we've already talked about, very few words can be objectively or like stably classified into a specific group of toxic or not. And that disturbs the model's ability to be able to do any sort of predictions on it, right? And the next question, and whether a word is healthy or toxic depends on the context and the community that's used it. So what happens when annotations is done when we're outside of the context? When the annotator, and particularly when the annotators are primarily based in the West, and we're looking at a very Western perception on what abuse is and what hate speech is. And it's important to question what idea of acceptability we're conforming to. And like, to like remove any kind of like whatever thinly veiled thing I have, or like how thinly it's veiled, it's white supremacy and it's white sensibilities. Like, what we are saying is that the dominant discourses are what's acceptable. Subaltern discourses and marginalized discourses are not. And this affects queer people, it affects people of color. It is just like a cis heteropatriarchal view on what we think is okay. And this particularly comes because content moderation acts as a third reader. So if you imagine that when you're communicating, there's a communicative intent between a reader and between a writer and a reader, an author and a recipient. Content moderation goes in and says, well, actually, we're going to add this third party in here who's going to make a judgment on what's acceptable or not. And this then becomes a question of power. Who has the power to define what constitutes toxic when no context is given? Like Facebook's guidelines famously or infamously denote that if it attacks on a group of people based on their race, ethnicity, or gender is not acceptable. But if you create a qualifier, then that's okay. So if you say, I hate all Asians, that might be flagged and be removed. But if you say, I hate all Asian cleaners, that's not going to be. And the fundamental difference here is very clearly one that takes some very specific hoops to jump through to identify. And they're white supremacist always for reasons unknown, or we know the reason. These are white supremacist companies that may be trying to do something good, but in effect, a lot of what they're doing is modern day white supremacy. The downstream effects of this are, there we go. Some bodies are policed as a result of which communities we base our understanding on toxic, and some are not. Some are protected and some are not. And what we're finding is, and what research in general is finding, is that the communities that are protected are the communities that need the least protection. So it's the communities that are least marginalized that gain the most protection. And conversely, it's the communities that are most marginalized in general, or that are most marginalized in life, that are policed the hardest. So we create a double-edged sword where they are both not protected and they get to be policed. They don't get to be policed; they are subject to policing. And this is all embedded in our models. From the use of pre-trained embeddings to the actual data annotation, annotators embody an understanding of toxic based on who they are, based on their situation. And then to how we optimize the models, do we sample some documents higher than others? Is there something that's iterated over more? Or are there some features that we think they are more important? Are we modifying that? Are we doing post hoc modification for fairness and so on? These questions all matter. And then there's obviously the specific type of model that we're using. Are we using a CNN, which assumes that there are some windows of sequences, some windows of feature sequences that are relevant for identifying whatever concept that we're looking at for abuse? And we examine perspective and opt-out, which are two tools for content moderation, and we find the logics of white supremacy and patriarchal and a patriarchal society are clear in that. And as some other people have shown, I can't remember their name right now, it will come to me. The paper's called is about drag queens and neo-Nazis. And what they're showing is that it's probably also transphobic, which is the least surprising thing in the world. So to label and model all of this, an implicit assumption is made that a third party, whether human or machine, without knowledge or context, can make a decision for others. And that might be okay in some instances, in others it's not. But the important thing is that we go back to the idea and question of, well, who are we really moderating for? Who are we creating the tools for? And let's recenter the people who need the tools. And as I've not so slowly been building up to, I think it's time to think about the political power that content moderation systems are under and that they enact and who they serve. So this is joint work with, comes from joint work with Samrika Lulz, Isabel Augenstein, and Joachim Bingel, and credit to Chris Dancy for the title State of the Art White Supremacy, which is also the title of my chapter. So here I look at Donna Haraway. Donna Haraway was a science and technology scholar who argued that science communication takes a view from nowhere and employs what she calls a God trick to portray ideas and findings as universal. This view from nowhere is no less embedded in sociocultural meaning than anything else. It just pretends not to be. So we're saying that, well, we're pretending to be objective, and this is what the object looks like. And this is what the object is. And we're saying the we and the perspective that we're looking at it from doesn't matter. We know the objective truth of this. Through this denial, perspectives that are embodied and are embedded and mired in context can be rejected as biased and not generalizable. So if you look at a square from the top and you say, well, I can see this square, and this is kind of how you can view this. You can see, well, you can say, I see this square and I understand this square fully. I understand what this looks like. But then if you go to the side of it, or someone else looks at it from the side and says, well, it actually looks different from here. You can say, well, I don't see that because I have the objective truth of it. And that's how a lot of science communication happens. And that's how a lot of machine learning is happening right now. We're saying that we are seeing things as they are and not as we have positioned ourselves to see them. And the way that we've positioned ourselves to see these things is disembodied, and through that is majoritarian and hegemonic. It is white supremacist. And this comes through from what we identify 4 different places where this disembodiment happens. So it happens in the designer, the person who owns the entire process of creating the model and creating the data sets. And because they can supersede annotators, they can supersede any decision that's made in any part of the process. They're rarely a part of the data or the imagined group of people who would be using this or who would be affected by it. So although they make all of these decisions and hold so much power, very often they are separate from the technology and from its uses. Then there's the annotation procedures. There's some third party, not people directly involved, who are annotating. So it's usually some group of crowdflower annotators, some students that are hired at the university to annotate the data. So they're making a decision on whether what you say to someone else is abusive, negative, ironic, sarcastic, whatever. They're making some they're making some normative decisions about your content. And some of it is based in theory. So if we look at if we look at the Penn tree bank, the way that that's tagged is based on some theory of how language acts. If we look at it, if you use another theory and re-annotate that data, we're going to get another data set. So it's not just in these higher level models, it's also in these, in the core NLP models. And I'm very happy that I got to make the core NLP pun. But another thing that matters is also, where are the annotators from? Where are they from culturally, geographically, physically? What are their lived experiences? All of these things influence how they operationalize the concept and what is being annotated. And when they annotate, they embed their perspective. And then, there are some things that are obvious. The annotation process, and there are some things that are obvious in the data selection. What data is collected, who is in it. Everyone who's not in the data is not represented. In terms of NLP, that means their language simply doesn't exist for the perspective of the model. It is not accepted as language that we'll consider. And even if in the imagined case where we manage to use everyone's data, we have all forms of language represented, all types of faces, whatever the machine learning task is. It still doesn't get to represent them because we always split the data into bite sizes, into, for instance, sentences, for the sake of the computer and the hardware limitations that there are. So we disembody the people, tearing them from proverbial limb from limb, to create something that is processable by the machine. And then we process them through these in NLP through these amalgamated bodies of others, through word that is word and contextual embeddings, things that are aggregated across a bunch of people, but by virtue of aggregating across a bunch of people, get to represent no one and everyone at the same time. And it's a fairly dangerous step, I think, but also one that has some benefits. So for modeling, a number of assumptions. We reduce each person's subjectivities and their positionalities to the moments that we see, and we call it features. So for modeling, a number of assumptions are made that bring us closer or further from the person that we're modeling on. And I argue that we present this as a spectrum between globalized models and localized models. Globalized models only use the data that is given, for instance, linear models. Localized models try to embody the person in context. And there are some methods that are doing this, but not really. So like transfer learning and multitask learning are ways where you can move your model closer towards being a localized model, but they're still not. Okay, 55 minutes, and let's quickly talk about future work. So I think that the future of content moderation technologies is dire. I don't think that we're heading in a positive direction. I think that a lot of the work that we've been doing in the field is, and this includes my own work, it is going down a path that we don't want it to. I think for us to be, there's some hopeful new work that is challenging that norm. I think that what we need to do is we need to, and this is for machine learning in general, but also for content moderation, particularly for content moderation, we need to recenter the people that we're talking about. We need to focus on not universal, but instead local, not global, but local. We need to understand that people are people, and people are people first, and we need to respect their humanity. Thank you. Thank you, goodbye.